Friction. Learning objectives. Introduction. Friction. Mechanism of friction. Causes of friction. Types of friction. Advantage and disadvantage of friction. Introduction. Friction. Let us discuss something very simple like with a pencil on a paper. Writing with a pencil requires friction. You could not hold a pencil in your hand without friction. The graphite pencil lead would not make a mark on the paper without friction. A pencil eraser uses friction to rub off mistakes written in pencil lead. Rubbing the eraser on the lead wears out the eraser due to friction, while the particles want gather up the pencil from the paper. Writing on paper with pencil. Erasing with eraser. In all machines incorporating parts with relative motion, friction is present. Friction is a natural resistance to relative motion between two contacting bodies. In most systems, friction has a negative influence on the performance of the system. Work done in overcoming friction in bearings and other mechanical components of machines is dissipated as heat, and its reduction will lead to an overall increase in efficiency. Since friction is a resistance force that slows down or prevents motion, it is necessary in many applications to prevent slipping or sliding. But also, it can be a nuisance because it can hinder motion and cause the need for expending energy. A good compromise is necessary to get just enough friction. In many instances, low friction is desirable. The satisfactory operation of joints, for example, whether hinges on doors or human hip joints, demands a low friction force. But low friction is not necessarily beneficial in all cases. In brakes and clutches, friction is essential. High friction is similarly desirable between a vehicle tire and the road surface just as it is between shoe and floor for walking. Definition. Friction can be defined as an opposing force which comes into action when two surfaces in contact with each other move relative to one another. This force applied between the two bodies resists the motion, and to overcome this opposing force an equal and opposite force is to be applied. Mechanism of friction. Frictional resistance to the relative motion of two solid objects is usually proportional to the force which presses the surfaces together as well as the roughness of the surfaces. Friction is in fact a very complex phenomenon which cannot be represented by a simple model. Saying that rougher surfaces experience more friction sounds most appropriate. Two pieces of coarse sandpaper will obviously be harder to move relative to each other than two pieces of fine sandpaper. But if two pieces of flat metal are made progressively smoother, you will reach a point where the resistance to relative movement increases. Reaching up to a point the smooth flat surfaces will actually adhere to each other, making what is called a cold weld. Causes of friction. As defined earlier, friction is a force resisting motion of an object when in contact with another. It is caused by the surface roughness of the contact area of the materials, deformations or the molecular attraction. 1. Surface roughness. Most common cause of friction is the roughness of the surfaces of materials being rubbed together. If we looked at what seems to be a smooth surface under a high-powered microscope, we would see roughness in the form of uneven surface that could interfere with sliding motion. Of course, the rougher the surface, the more the friction. Similarly, treads or grooves as seen in automobile and bicycle tires is another form of roughness of the surface which increases the friction, especially if the treads have sharp edges and are not parallel with the line of motion. Bicycle tire moving on road. 2. Molecular adhesion. Another factor in friction can be caused by molecular adhesion or attraction. Ultra-smooth materials and sticky materials fall in this category. A. Ultra-smooth. If surfaces are ultra-smooth and flat, the friction from surface roughness becomes negligible, but then friction from molecular attraction comes into play. This can often become greater than friction if the surfaces are relatively rough. B. Sticky materials. Rubber is an example of a material that can have friction caused by molecular attraction. Discounting resistance due to deformations with rubber, it is its stickiness factor that causes it to grip so well and to have so much friction. C. Friction in fluids. Fluids often exhibit molecular adhesion, increasing the friction. One example is how a coin will easily slide down a ramp. But if you wet the coin, it will stay in place. Flat is because of the molecular friction of the fluid on the hard surfaces. Holding rubber. 3. Deformation. Soft materials will deform when they are under pressure. This also increases the resistance to motion. For example, rubber tires flatten out at the area on contact with the road and cause more friction. The standard friction equation holds for hard objects being held back by surface roughness. Activity 11.1. Aim: to understand static friction, limiting friction and dynamic friction. Material required: a hook fixed wooden block, a good sensitive spring balance. Method: place a wooden block fixed with a hook on a smooth tabletop. Attach a good sensitive spring balance to the hook fixed on the wooden block. Now gently try to pull the block on right side. You will notice that gentle pull does not move the block, but spring balance shows the force applied on the wooden block. This force registered by the spring balance is equal and opposite to the force of friction offered by the wooden block in contact with the tabletop. Now, increase the force applied to the wooden block. You will notice that the wooden block has not moved, but the spring balance records a higher magnitude of applied force. From this observation, this can be concluded that, when the wooden block does not move, then the applied force is equal and opposite to the force of friction offered by the surface of the tabletop to the wooden block. Such a force of friction is called static friction, and this is the force necessary to prevent the motion of the wooden block. Now keep on increasing the force applied on the wooden block, till it just starts moving. At this moment, spring balance records maximum force applied, which is equal and opposite to the force of friction. This maximum force required to make one body to just slide over another body is called limiting friction. If we further apply the pull on the wooden block in such a way that it starts sliding over the tabletop, then the spring balance records a force lesser than the limiting friction. This lesser force registered by the standard friction equation holds for hard objects being held back by surface roughness. The spring balance which keeps the wooden block just sliding on the tabletop is called the dynamic or sliding friction. Types of friction. 1. Static friction. Static friction occurs between two objects are not moving relative to each other, like a book on a desk. The coefficient of static friction is typically denoted as the initial force to get an object moving is often dominated by static friction. The static friction is in most cases higher than the kinetic friction. Rolling friction occurs when one object rolls on another, like a car's wheels on the ground. This is classified under static friction because the patch of the tire in contact with the ground, at any point while the tire spins, is stationary relative to the ground. The coefficient of rolling friction is typically denoted as wooden block on table, car tire on road. 2. Kinetic or dynamic friction. It occurs when two objects are moving relative to each other and rub together like ski slides on the ice. The coefficient of kinetic friction is typically denoted as and is usually less than the coefficient of static friction. Since friction is always exerted in a direction that opposes movement, kinetic friction always does negative work. Ski sliding on ice. 3. Fluid friction. It is the friction between a solid object as it moves through a liquid or a gas. The drag of air on an airplane or of water on a swimmer are two examples of fluid friction. 4. Limiting friction. The maximum static force of friction called into play when one body just slides upon another body is called limiting friction. The limiting friction is always slightly more than the dynamic friction because more force is required to unlock irregularities between the surfaces of two stationary bodies as compared to the force required to keep the irregularities unlocked between the surfaces of two sliding bodies. Laws of limiting friction. I. Limiting friction is always opposite to the direction and motion of a body. 2. Limiting friction depends upon the nature of the surface in contact with each other. 3. Limiting friction increases with the increase in the weight of the body. 4. Limiting friction is independent of the area of the surfaces in contact provided the weight of the body and nature of the surfaces in contact does not change. The following activities will be able to explain this in more details. Swimming in water. Activity 11.2. Aim. To prove that friction depends upon the nature of surfaces in contact with each other. Material required: 2 pieces of square wood about 5 inches by 5 inches, and dishwasher soap. Method: take 2 pieces of wood and put one on the other. Now lay a hand on the top piece and try to move it. The friction is too strong to allow the movement. Place liquid dish soap between the 2 pieces and see how will they move when we place our hand on the top piece of wood and move our hand in a clockwise motion. Conclusion: to make anything start moving, a force is needed. When 2 pieces of wood are on top of each other, the friction is probably too strong to move the top piece of wood by laying hand on the top piece. But if we place a safe liquid like dish soap between the 2 pieces, the lubrication will reduce the friction and the wood will move easily. Friction is important in the Newton's first law of motion because when 2 things rub together, it causes friction. Friction opposes motion and makes things slow down. Once moving, a force is needed to stop things. 5. Rolling friction. First, let us perform the following activity. Activity 11.3. Aim. To prove that rolling friction is far less than limiting friction. Material required: a wooden block fixed with a hook, a spring balance and 4 to 5 pencils with round surfaces. Method: first repeat the activity 11.2 with the wooden block and note down the limiting friction of the wooden block on the tabletop. Now place the round surface pencils parallel to each other on the tabletop with a distance of 2 cm between them. Over these pencils place the wooden block in such a way that when force is applied on it, the pencils roll under it in the direction of the applied force. Attach the spring balance to the hook of the wooden block and gently pull the spring balance towards the right side till it just starts sliding over the pencils. Conclusion: you will notice that the force required is much lesser than the limiting friction. This force of friction is called the rolling friction. Rolling friction can be defined as the friction experienced by a body when it is made to roll over another body. This is a resistive force that slows the wheel's motion on the other surface. Causes of rolling friction. Rolling friction is caused by the following factors. 1. Deformation of the ground. The wheel or roller deforms the surface on which it moves because of its weight, and a force is required to overcome this deformation, causing rolling friction. Rolling friction. 2. Deformation of the wheel or tire. The wheel takes on a sort of flowing motion resulting in increased deformation at the front of the wheel, while the rear of the wheel undergoes little deformation, which results in the majority of the normal force being located at the front. An inclined plane is formed in the direction of the motion of the wheel because of these 2 above-mentioned deformation. Thus, a force is required to overcome this temporary inclined plane which is continuously moving forward. This applied force against the continuously moving forward plane is equal to the rolling friction. Rolling friction depends very much on the material of the wheel or tire and the sort of ground. For example, rubber will give a bigger rolling friction than steel. Also, sand on the ground will give more rolling friction than concrete. An advantage of rolling friction is that it is much less than sliding friction. Because of this reason, rolling friction is more preferred than the sliding friction. In our daily life, we see a number of devices using rolling friction in the forms of wheels, ball bearing, etc. to take the advantages of this property of rolling friction. Examples of rolling friction. 1. One of the fastest means of mass transport is trains. The wheel as well as the train tracks are made up of high-quality steel. As the steel is very tough, there is a very little amount of deformation of wheels or tracks occur while moving. Therefore, a lesser force is required to overcome this resistance, and hence we get faster movement with lesser energy expenditure. Train wheel on track. 2. The roads are made up of concrete or coal or mixed with hard stone. The roads are compacted very hard with the use of heavy rollers, so there is minimum depression of the road surface when vehicles move on it. Secondly, the types of vehicles should have adequate pressure in the tire to reduce its deformation to minimum levels. 3. Heavy equipments are provided with wheels so they can be moved easily. You must have noticed that there are wheels in some of the furniture at your home. Your TV trolley also has wheels to move your television easily. 4. In big thermal electricity producing plants, huge amount of coal is fed through the conveyor belts which moves on big ball bearings to the steam producers. TV trolley with wheel. Friction, liquids and gases. Till now, we have discussed the friction of solid objects when they move in relation and contact with each other. Similarly, when a solid object moves through liquid or gas, its surface experiences friction. When a solid object is in contact with a fluid, such as a liquid or gas, and a force is applied to either the object or the fluid, there is a friction force that resists the motion. Examples where fluid friction occurs are water flowing through a hose, an airplane flying through the atmosphere, and oil lubricating moving parts. The friction exerted by the liquid on the surface of solid object is lesser as compared to solids. Similarly, gases exert least force of friction in comparison to solids or liquids. As the water and air are the most common liquid and gas available in our surroundings, we will discuss friction due to water and air. Friction due to water. The causes of fluid or water friction are turbulence effects from surface roughness and deformities, molecular attraction or adhesion between the materials, and deformation resistance of the fluid. Factors that determine the amount of fluid friction on a solid object include the viscosity of the fluid, the surface texture of the solid object, and the shape of the object. By changing any of these factors, you can increase or decrease the amount of resistive force of fluid friction. Streamline shape. The special shape of a body around which fluid or air can flow with minimum of friction is called a streamline shape. Examples. A. The bodies of boat and ships are made in a streamlined manner so water offers least resistance or friction for their movement through the water. B. When swimmer swims in the water, he tries to move in the water by making him streamlined, thus offering less resistance. C. Most of the water animals, especially fishes, have their bodies naturally streamlined, suitable to their water habitat. D. As water offers less friction, stopping big ship becomes a tricky job. Big ships have to fire their engines in the reverse direction to stop themselves. Boat on river surface. Swimmer swimming. Fish swimming. Friction due to air. Air friction is to the object moving through the air which having to move molecules of air aside. The larger the object, the more air has to be moved aside, and so the larger the air friction. Even surfaces parallel to the direction of motion of the object generate friction, since molecules of air collide with the surface and are so pushed in the forward direction by the collision. By Newton's second law, action and reaction, they push back on the object, thereby generating more air friction. There is a lot of drag if the shape of an object disturbs the air a lot. For example, if you push a flat plate through the air, it leaves lots of whirls of turbulent air behind it. It requires energy to create that turbulence and gets more air friction. On the other hand, a smooth aerodynamic shape leaves hardly any turbulence behind it after it goes by. Examples: A. When an airliner lands and is trying to slow down, large flaps on the wings provide a flat surface and extra air resistance to help the aircraft come to a stop. B. Kite flies in the air because of the friction and resistance offered by the air to the kite. C. A pilot jumps from the aeroplane with the help of parachute in emergency situation. The air friction prevents the rapid fall of pilot on the land, thus saving his life. D. In nature, we see the bodies of birds which are light and streamlined to help them fly. They get least friction from the air. E. The bodies of aeroplane, cars and other vehicles are streamlined to reduce the force of air friction opposing their movement. F. As the air friction at high speed produces intense heat, the spaceships are provided with special heat shield to provide safety to them when they enter the Earth's atmosphere. G. Have you seen the shooting stars? These are meteors which start burning when because of the air friction as they enter the Earth's atmosphere. H. Opening the windows in your car increases the air resistance due to the airflow inside the vehicle. Airplane landing show wheels. Pilot and parachute. Advantages of friction. Friction is a resistance force that slows down or prevents motion. It is necessary in many applications to prevent slipping or sliding. But also, it can be a nuisance because it can hinder motion and cause the need for expending energy. A good compromise is necessary to get just enough friction. Friction is also very important and beneficial. There are many things that you could not do without the force of friction. Let us discuss few examples. 1. Walking. You could not walk without the friction between your shoes and the ground. Friction holds your shoe to the ground, allowing you to walk. This is the reason to find how difficult it is to walk on slippery ice, where there is little friction. 2. Writing. Writing with a pencil requires friction. Without friction we will not be able to hold the pencil. The graphite pencil lead would not make a mark on the paper without friction. 3. Driving vehicles. Your car would not start moving if it wasn't for the friction of the tires against the street. With no friction, the tires would just spin as sometimes we encounter on wet and slippery roads. Likewise, you could not stop without the friction of the brakes and the tires. Walking. Writing on paper. Moving car. 4. The force of friction holds the nails and screws in the wood and other material, making possible to build anything. 5. We see metallic treads on heavy vehicles like tank. These treads provide the high friction required to move such a heavy vehicle. This is also true for other heavy machinery. 6. Lighting a matchstick is a function of friction, as friction produces heat when matchstick is struck on the rough surface provided on the matchbox. The raised temperature makes the chemicals at the matchstick head to catch fire and produce flame. Disadvantages of friction. Disadvantages of friction. 1. Anytime you want to move an object, friction can make the job more difficult. Excess friction can make it difficult to slide a box across the floor, ride a bicycle or walk through deep snow. 2. An automobile would not move forward very well unless its friction was not reduced. 3. Oil is needed to lubricate the engine and allow its parts to move easily. Oil and ball bearings are also used in the wheels, so they will turn with little friction. 4. Wastes energy. In any type of vehicle such as a car, boat or airplane, excess friction means that extra fuel must be used to power the vehicle. In other words, fuel or energy is being wasted because of the friction. 5. Fluid friction or air resistance can greatly reduce the gas mileage in an automobile. Cars are streamlined to reduce friction, but driving at highway speeds with your windows open can create enough drag on the car to greatly reduce your gas mileage. 6. The energy that is lost to friction in trying to move an object is really turned to heat energy. The friction of parts rubbing together creates heat. Besides the problem of losing energy to heat, there is also the threat of a part overheating due to friction. This can cause damage to a machine. 7. Any device that has moving parts can wear out rapidly due to friction. Lubrication is used not only to allow parts to move easier but also to prevent them from wearing out. Some other examples of materials wearing out due to friction include the soles of your shoes and a pencil eraser. Ball bearing. Friction, good or bad? Friction is necessary in many applications to prevent slipping or sliding. But also, it can be a nuisance because it can hinder motion, waste energy, brings about wear and tear. A good compromise is necessary to get just enough friction or a proper combination of frictions. How to reduce friction? The most basic reason of friction is the surface irregularities, and therefore most of the methods work to reduce these irregularities. Let us discuss few methods for reducing friction. 1. Lubrication. A common way to reduce friction is by using a lubricant, such as oil, that is placed between the two surfaces, often dramatically lessening the coefficient of friction. The lubricants separate the two surfaces by creating a thin film between two surfaces, thus majorly reducing the irregularities and consequent friction. The science of friction and lubrication is called tribology. Superlubricity, a recently discovered effect, has been observed in graphite. It is the substantial decrease of friction between two sliding objects, approaching almost zero levels. 2. Converting sliding friction into rolling friction by using devices. Devices, such as ball bearings, wheels etc. can change sliding friction into much smaller rolling friction. Ball bearing. A ball bearing contains a set of balls between two rings. The inner ring can rotate easily while the outer ring does not move. The bearing can be used to support a rotating shaft, which is fixed to the inner ring of the bearing. 3. Streamlining. The third way of reducing friction is very important in transport, especially in aircraft. Streamlining gives the transport a shape that moves more easily through air or water. It has a pointed nose or bow and smooth sides, which do not push strongly against the air or water. Reducing friction by streamlining an aircraft or car can give it a higher speed. Streamlining can also save fuel if speed is not increased. Many birds are streamlined so that they can swim at speed, catch prey and dive through the air or water. Streamlined shape of airplane. 4. Slacking techniques. One technique used by railroad engineers is to back up the train to create slack in the linkages between cars. This allows the train to pull forward and only take on the static friction of one car at a time, instead of all cars at once, thus spreading the static frictional force out over time. 5. Surface characteristics modification. You can reduce the friction by improving the surface characteristics or texture of the solid object by methods like polishing. Seldom are the surface characteristics changed to purposely increase the fluid friction. 6. Turbulence factor. If a golf ball had a completely smooth surface, it would not fly as far as an identical ball with a dimpled surface. The reason is that each dimple creates a small area of turbulence on the surface. This means the air is then flowing over air in that area and not along the surface of the ball, thus reducing the resistive friction. Keywords. Friction, an opposing force that comes into play when one body actually moves or even tries to move over another body. Sliding, the smooth move over a surface. Limiting friction, maximum opposite force when one body is just at the verge of moving over the surface of another body. Static friction, the opposing force that comes into play when one body tends to move over the surface of the other body but actual motion is yet to start. Kinetic friction, the opposing force that comes into play when one body is actually moving over the surface of another body. Streamlining, the shape of something so that it can move as effectively and quickly as possible through a liquid or a gas. Lubricant, a material used to decrease friction. Summary. Frictional resistance to the relative motion of two solid objects is usually proportional to the force which presses the surfaces together as well as the roughness of the surfaces. Most common cause of friction is the roughness of the surfaces of materials being rubbed together. Static friction occurs when the two objects are not moving relative to each other, like a book on a desk. The friction exerted by the liquid on the surface of solid object is lesser as compared to solids. Similarly, gases exert least force of friction in comparison to solids or liquids. An inclined plane is formed in the direction of the motion of the wheel because of these two above-mentioned deformation. By changing any of the factors, you can increase or decrease the amount of resistive force of fluid friction. Air friction is due to the object moving through the air having to move molecules of air aside. A way of reducing friction is lubrication.